Hey guys, so today we're looking at the last part of 2.2, which all it is covering piecewise functions. We've got a day just for piecewise functions. So if you already know how to graph piecewise functions, then by all means skip to the homework. If not, let's get into it because a lot of students find these very confusing. I'll do my best to make sure it's not confusing. Now, don't start writing all this stuff, okay? Don't start writing all this. I'm going to have, I will recommend that you write this stuff um, at certain points, and I will tell you those points. So, graphing piecewise functions the easy way. Right? This is how I will be doing it to start with, to teach you guys what they are, if you've forgotten. Now, I mean, piecewise functions are in Algebra 2. Now, this is like a sketchy topic. Most of the stuff we go over for a long time is like you should have already learned it. If I'm going to be totally honest, it was an Algebra 2 concept that you tested over that you should have known. But I'm treating everyone like Algebra 2 students, so that you haven't learned this, you don't know what's going on. Right? That's probably for the best. But hopefully something about this will be familiar to you. Anyway, so here's what a piecewise function looks like. Now, what I want you to do. Oh, wait, actually. Oh, I can actually do this. Oh, this is going to be awesome. Oh, look at that. Look at this. This box is an error, and it's not even supposed to be here. Get out of here. Get out of here, box. Nobody likes you. You're ugly. All right, so a piecewise function. This says f of x, by the way. It is a function that is defined in two different ways based on where you're at on the graph. So everywhere to the left or less than or equal to 1, it looks like the line x plus 2. And everywhere that is bigger than 1, it looks like the line 4. And this is, remember, f of x is like y. So this is like saying y equals x plus 2, y equals 4. All right? So, first things first. Graph all of the functions on a single xy plane. So if we were to graph y equals x plus 2, I'll graph this one in purple. So y equals x plus 2. So y-intercept of 2, this is in slope-intercept form, guys. Then it's got a slope of 1. So up 1 over 1. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, down 1 over 1, down 1 over 1. All right. All right, there's that line. And then I'm going to graph y equals 4 in green. So that's a horizontal line through 4. Okay. So this is where I would write, if you're looking to do this the easy way, or the way that is the simplest, I guess it's slower, but it's the simplest way, then you graph all of the functions. There might be more than 2, there might be 3 or 4. All of these pieces, graph them all on a single graph. Then, here's the next thing you do. You draw a vertical line through the inequality values. So our inequality value, there's only one of them. There's an inequality value at 1. So we're going to draw a line through 1, okay? So that's right here. And this is like if you're going to do this on your paper, do it as a dotted line, okay? So this is the cutoff point, all right? Remember, this piecewise function states that the graph only looks like the purple piece if x is less than or equal to 1. And then it looks like the green piece if it's greater than 1. So here's where the next step comes in. Put points, open or closed circles, on the graph where the inequalities are focused. Make sure to put them in the correct function. So here, we have to consider what is going on at x equals 1. Is it this function or this one here? And I know that this is all one function, but I mean if you were to separate them. So where is your function at exactly 1? Well, here, look. This is when you're equal to 1. You use this function. So, when you're equal to 1, you use this one here. That means on 1, wherever the graph is at 1, on the purple function, you're going to have a closed circle because you're equal to it. So here is 1, here's where it's at, so we have a closed circle here. That's where the graph touches at x equals 1 on the purple graph. Then you look at the other one. It's a not equal to. That means you're going to have an open circle at 1 on the green graph. So here's where it touches at 1, open circle. I should use my dark green. Open circle. And let me make it really clear that it's open by removing everything from inside it. All right, open circle on the green line at the same spot. Then decide which function goes where and erase. So for the values less than 1, it's purple. That means it is not green. So I'm going to erase all of the green. You've got to erase all the green. What does this look like? All right, so if it's the purple graph at less than 1, that means it's not the green graph. So you just erase all of the green. Okay, and then for x is greater than 1, it's the green graph, aka not the purple graph. So going to the right, you erase the purple graph. And here's how I think of this whenever I am going through it in my head. I look at the piecewise function, and I say, on the left of 1, because it's less than, on the left of 1, it's a diagonal line, because this is a diagonal line. And then, to the right of 1, it's a horizontal line, because it's, y equals 4. So I think, does this look that way? To the left of 1, it's a line that's diagonal. Very good. To the right, it should be a horizontal line. To the right, it's a horizontal line. This is the basics of what a piecewise function is. It is a function, a single function, that is defined differently based on what your x value is. Okay? Piecewise functions are actually very popular. There's lots of things that are dependent on certain variables, and we might get into modeling later on, but students don't really like modeling. And in Algebra 3, we typically avoid it just because, we don't have to do it. So let's go ahead and erase these boxes just to get them out of here. Okay, so let's graph this. And we're gonna do this in the same exact manner. Okay, how many more piecewise functions do we have? Okay, just 2 more after this one. So we'll do this one again the slow way. The slow and steady wins the race kind of way. So first things first, graph both of these. So if you want to do that, go for it. This is like y equals 3, and I'm going to do this in, let's do this in this dark purple. Y equals 3 looks like this. And then let's do this in pink. Or it doesn't look pink when it's this dark, but this different color here. So this is a diagonal line, y-intercept of -2, slope of 1. Y equals mx plus b. Slope of -2, or wait, y-intercept of -2, slope of 1. That's a little off, but whatever. Okay, so let me zoom down and keep going here. All right, so the next thing is to draw our border, basically the border between this and this. And that is at, whoa, look at this. This should read a -1. This is a typo. Don't let this confuse you. This is a typo. Typically, these will be the same number. Typically. All right, so that should be a -1. All right, sorry about that. So to draw our border, that's it. The border is at this value here. Actually, let's use a different color. Let's use this, this nice blue. The border is this value here. All the values that show up here. So this is -1. X equals -1. So we're going to draw a border through x equals -1. Okay. So then we look and see. On the purple line, there's the purple line. If I have my purple out, here's the purple line. You're equal to it at -1. So we go to the -1, and we would have a closed circle since we're allowed to touch. And then here we're not equal to. So on the pink line here, we'd have an open circle at -1 because we don't equal it. So here we have an open circle. Open circle where we touch at -1. So right there. And just for convenience sake, I will erase the stuff in the middle. All right, open circle. Then, at values less than -1, we look like the purple line. So only the purple at values less than -1. So basically, everywhere over here, everywhere to the left, all of this area needs to only be the purple. So that means all the pink has got to go. So let's make this a little bigger here. Everywhere to the left of -1, it's only the purple. And then everywhere that is bigger than -1 to the right is only the pink. So all the purple needs to get gone, right? The graph is only supposed to be pink on greater than -1. So all of this has got to go. Okay. And there you have it, your piecewise function. It's a horizontal line disjointed into a diagonal line. Okay? Now, here is a more complicated function. So, let me give you another way to do these. A good way to do these is to have good background knowledge of what the functions would look like by themselves. This is a parabola, and I'll go ahead and draw like a little parabola. This is a parabola, and this is a line that's going downward because it's got a negative slope. So this is what these will roughly look like. So I'm going to go ahead, and here's the quick way, right? The quick way. Plug this value into this function and see what you get. So I'm showing you the quick way now. Plug in that value, whatever it is, into your function, into this piece of it. So you'd have -1 squared plus 2, which is 1 plus 2, which is 3. So at -1, we are at 3. And if you notice, this is an equal to, so there would be a closed circle there. So at -1, 3, there's going to be a closed circle on this one here. So I'll use the red for this. So at -1, 3, -1, 3, closed circle. Then I use my general knowledge of a parabola. This is a parabola that is it's a typical parabola that's moved down to. So the parabola should look something like this. Is that really? Oh, I was thinking something's weird's going on here. My apologies. I have made a terrible error. If you look here, there's a minus sign. Minus sign. I do have eyeballs, and they do work most of the time. So this should be 1 minus 2. My bad. And students are like, what are you doing? Don't worry, I catch it. I caught it. I was wondering, something crazy is going on. So this is a minus 2. Minus 2. So this is not 3. Stupid me. This is actually -1, and that makes a lot more sense. -1, -1. So -1, -1. Right here. That makes a lot more sense. So I know that this looks like a parabola, which means it would look like this. I envision this in my mind. It looks something like this. Right, let's get this curve. Looks something like that. I'm not too worried about the precise accuracy of this curve. So I know that it looks like that-ish. So if it's supposed to look like a parabola, but only a value is less than or equal to -1, that means to the left. To the left of this dot, it looks like this. So what I'm going to do is just draw that parabola curve over here. Just like that. And then, actually, perfect. Then it looks like this line. Actually, I should have done this in the red. What am I, some sort of stupid person? Don't answer that. All right. Actually, whoa, I'm wasting time with these terrible parabolas. That'll do. All right. I don't want to waste your time. So then you do the same thing with this one. You plug in -1 into here, see what you get. Plug in 2 into here and see what you get. So we've got to plug in -1. So negative times -1 plus 4, because there's a negative here, and then you're plugging in -1 into x. That equals 1 plus 4, which is 5. So at -1, you're at 5. And then you plug in 2. -2 plus 4. -2 plus 4, which is 2. So here you're at 2 comma 2. Oh, wow. Okay, so what this means, you want to plot both of these points, and you want to plot them with certain circles, whether they're open or closed. And you look at the inequality that links them. So if you're paying attention, there's a strictly less than, not an equal to. So that means at this point here, you'll have an open circle. So this would be an open circle. And then you look here, not equal to again, open circle. And why did I not include, this is dumb of me, open circle on both of these. So let's put an open circle on both of them. -1, +5, -1, +5, 1, 2, 3, 4, 5. And then 2, 2, 2, 2. And I know it is a straight line, and I know it's got to connect these 2 points, so let's go ahead and do that. Boom, your piecewise function is done. And once you get good at this, all it really is plug this into here, plug this into here, plug this into here, plot those points with either open or closed circles, and then draw the shapes. That's it. And I will show you how fast you can do these if you understand that concept. All right, so this is how you do them. Hopefully this next one will really cement what it is we're doing. And if it doesn't, you need to ask, especially on the homework problems. All right? So I'll do this in blue. So we'll get started. This one's in blue. Whoa, that looks like not what I want. So -2. Plugging a -2 into here. -2 plus 2. That's a +2 plus 2, which is 4. So -2, 4. Plotting -2, 4. That is a straight line with a slope of -1, and it's to the right. Excuse me, that is an open circle. Open circle because it's not equal to. And this is a slope of -1, which means it would go down 1, right 1, down 1, right 1, down 1, right 1, which means it would look like this. Okay, next, plug in -2 into here. So this one will be, let's make this one green. Plug -2 in. So plugging this, so it's going to be an open circle, and I'm going to plug in -2. So that's going to be a -4 plus 4, which is 0. So we've got -2 comma 0. So we've got an open circle at -2, 0. Then we plug in 5, and this is going to be a closed circle. So closed circle, plugging in 5. And you're going to get -25 plus 4, which is -21. So you've got 5 at -21. So then we have a closed circle here. So I'm just going to go ahead and say that this is 1, 2, 3, 4, 5. I'll say this is -21. It's a closed circle. And connecting these two is a parabola that is opening upside down. So I know squared functions are parabolas. I know the negative sign flips it upside down, and I know the +4 makes it move up 4. So instead of looking like this, right, instead of looking like this shape has moved up 4, and it's moved upside down. So we go up 1, 2, 3, 4, and it's upside down, and it looks like this. Exactly so. Then I don't even have to worry about this. Plugging 5 in, because it's going to be 3. There's not even an x to do anything with. So it looks like a horizontal line at 3, at 5. So 1, 2, 3, 4, 5. At 3, there's an open circle, not equal to. And it looks like this. Yep. There we have it. There's our piecewise function. I think piecewise functions look pretty cool once you graph them. Pay attention to the open circles and the closed circles based on the inequality. Plug the end points in. That's really what's most important. And then draw the shapes in between. There's your homework. This I predict you will have questions over. Please ask them. Please, please, please ask them. Do your homework. Otherwise, you're going to do poorly on quizzes and tests, and I will catch you on the next lesson.